Hey boys and girls, meteorologist Steve Caparata back with another episode of Cap's Corner Summer Camp, episode 5 of the summer. And today we're going to talk all about weather satellites. So last week, if you're with us, we talked about radar, and I said radar shows us what? Rain, right? Well, satellites, more about clouds, although as we get deeper into the lesson, I'm going to show you some really cool things besides clouds that we can see with satellites. There are two main types that we use in weather. The first one that we use most often, it's a big word, but see if you can say it with me, geostationary. Okay, we use geostationary satellites. What does that mean? Well, this picture is trying to show us. You see the satellite, how it's orbiting around the Earth, and this line, what it's showing here is that the satellite orbits at the same speed that the Earth rotates. And what does that do? That keeps it over the same spot on Earth at all times. Look at how high up they are, about 22,000 miles up above us. So we launch them out into space on a rocket. They go into orbit 22,000 miles above us. They kind of position them right above the equator. And again, that speed that they orbit, it matches the speed that the Earth rotates. That's at roughly 700 miles per hour. So those are geostationary satellites. Another type that we use a little less frequently in weather, but we still use, is called a polar orbiting satellite. So what's a polar orbiting satellite? Well, as the name kind of implies, it is one that actually goes over the poles. That's what this animation is showing us here. So remember, our geostationary, those are about 22,000 miles up above us. The polar orbiting satellites are only 100 to 600 miles above the surface of the Earth, typically speaking. Now, they only catch the same spot on Earth twice daily. So remember, our geostationary, they stay on top of the same part of Earth at all times. Since these polar orbiters are going over the poles while the Earth rotates, they only catch the same spot on Earth about twice daily. Now, since they're at a lower altitude, closer to the Earth, the resolution is better. Give us clearer pictures, generally speaking, than the ones that are 22,000 miles up above us. And it typically takes a little bit under 2 hours for it to complete that orbit. So they're moving pretty fast as they orbit the poles. Our first weather satellites came about 60 years ago. The first one was called TIROS-1. It was created by a company called RCA. The moms and dads will remember RCA. A lot of us grew up with RCA TVs and radios and electronics, but this one was launched in 1960. This is it right here in the picture. It had 2 TV cameras on it, 2 video recorders with it, and get this, it only lasted a couple of months up in space before that was it for TIROS-1. Now, here's the first image it's sent back to Earth, and boy, it's kind of hard to imagine satellite images looking like this in this day and age, right? But this is what the very first image looked like. Kind of hard to make out much, just big white blobs. Those were some of the clouds. Started to see things progress after that, though. For example, about 5 years later, this is a satellite view of Hurricane Betsy in 1965, a real historic hurricane that hit Louisiana. So at least you can kind of make out the hurricane here and the eye in this image as it was kind of coming across Florida into the Gulf of Mexico. Still pretty blurry, but better than what that TIROS-1 image looked like in 1960. 4 years later, continuing to get better. This is Hurricane Camille, 1969. Now we're starting to see more detail here in the hurricane. Again, this one moving into the southeastern Gulf of Mexico, Louisiana up in here. This one would brush Louisiana and make landfall in Mississippi as a Category 5 hurricane. Remember, Category 5 is as strong as they come, but starting to get a little bit better by the late 60s, but still nowhere near what we have today. Now let's fast forward, and boy, look at how our satellites have come along through time. This was Hurricane Katrina in 2005 when it was near its peak strength. It was a Category 5 hurricane at this point in time as it was heading towards Louisiana. Maximum winds, I think, were around 175 miles per hour, if I remember right. But look at how much more detail we had by 2005. So certainly our satellites have come a long way in time, and they continue to get better. We continue to get more detail with them, like this. This was Hurricane Dorian just a few years ago, approaching the Bahamas. And look at how amazing, how much detail we can see within the eye of the hurricane here. And not only the amount of detail we can see, also now with some of our more modern satellites, we get the images much more often. It used to be some of our satellites, we'd only get a new picture, a new image, maybe every half hour, every hour in some cases. Now in cases like this, they can have some of our satellites give us a new image about every minute, and that's how you get a really detailed and kind of smooth animation or smooth movie like we have there with Dorian. So fast forward to what we're dealing with now, and what kind of was giving us some of those views of Dorian. GOES 16, we have 17, but these are our modern satellites. GOES, the G in that stands for geostationary, okay? So these are our geostationary satellites that we use most often in weather. But our more modern geostationary satellites do a lot more than show us just clouds. We can see clouds, we can see fog, we can track wildfires with them, we can look at vegetation, we can see volcanoes, we can see aerosols, pollutants in the atmosphere around us. We can track ozone, which we know is important also. Many things we can now track with our modern day satellites. What's neat about the latest generation of satellites is now they have some lightning sensors on them. So we're doing new research with regards to lightning with that new sensor that we have on board. And what does all this mean? Best spatial and time resolution. Yet when we say best spatial resolution, we mean the most detail we've ever had in our satellite pictures, the clearest views we have on our weather systems and clouds. And not only that, as I was mentioning, now we get those images more often than we ever have before. So pretty amazing to see how satellite technology has progressed through time. So let's talk about a few key types of satellite imagery that meteorologists use. And it's important to know what each of these types of imagery is used for. So this is what we call a visible satellite image. It was captured one day, one morning over the deep south, over the southern United States. Now, what's real important to know about visible satellite is that it relies on reflected sunlight. So that means since we need sunlight reflected off of the clouds in order to see those clouds, we can't use visible satellite imagery at night. We can only use this during the day. And even when it's around sunrise and sunset, when the sun is low on the horizon, visible satellites are not very usable either. You need that sun to get a little bit higher up in the sky to get the reflected sunlight, okay? One thing to know about visible satellite images is sometimes it can be a little bit difficult to distinguish between clouds in the lower part of the atmosphere, the mid part of the atmosphere, and the high part of the atmosphere. Now, trained eyes and people like me have been at this for a long time. Sometimes you can distinguish the differences, but that's one of the challenges with visible satellite. We also use water vapor satellite imagery in weather and meteorology. Here's what's important. This is something that gets a little bit confused sometimes. So as you look at this, all the white here, this isn't really clouds. This is the satellite actually detecting water vapor. So if you're with me, I think it was the very first lesson where we talked about the water cycle, okay? One of the things we talked about was the 3 states of matter for water. So water is a liquid. Water as a solid is ice, right? And then water in the form of a gas is water vapor. We can't see it around us, okay? We can feel it. We can feel that as humidity, but we can't see it. So reason I'm distinguishing here why this is the satellite detecting water vapor and not clouds. The water vapor is invisible. So this satellite, all of this white is not necessarily cloud cover, okay? That's important to know when you look at water vapor imagery. Now, when we use the water vapor, this focuses more on the mid and upper part of our atmosphere, not so much what's happening closer to the ground. So this type of satellite imagery can be good for tracking what we call these upper air disturbances. What is that? Well, an upper air disturbance in weather and meteorology, this is kind of a little feature that'll be moving through the atmosphere that will often lead to clouds developing, maybe rain and storms, and we can more easily pick up on some of those features on the water vapor satellite image. We can also pick up on areas of drier air. For instance, on this particular image, if you see here on the right edge, it's more of a shade of like brown and orange. That's indicative of some drier air. So that's something else we can do with water vapor. And then the third main type of satellite imagery that we use in weather and meteorology is called infrared. And here's two different versions of infrared. I've got one where we kind of show the clouds as shades of gray and white. And then the very same, an image taken at the same point in time where it's colorized. And all we're doing here is using our computers to add some color to the clouds on our computer. Doesn't look like that out in space. Our computers are doing that for us, and it helps meteorologists pick out some of the features that we want to track. Most often what we're looking for here when we have a colorized version, typically where you see maybe shades of yellow and especially orange and red, that's where we're looking for our taller clouds and where our bigger storms typically are. So you look at something like that. So infrared, what we're really doing is sensing heat or heat energy emitted from the clouds. Okay, the advantage to this, say over visible satellite, is that our infrared satellite imagery is available 24 hours a day. Remember, visible needs reflected sunlight. In this case, we're sensing heat energy, and that's available 24 hours a day, so we can use it all the time. Now this one, sometimes, especially in the winter months, it can be a little bit difficult to distinguish between low clouds and fog and what is actually the ground. So since this is sensing temperatures in essence, and in the winter months the ground gets colder, our clouds also tend to be a little bit cooler. Sometimes the satellite will start to kind of paint in what looks like a cloud, but really that's because the ground temperature and clouds above are pretty similar in the winter, so it may not even be clouds. So we have to be careful as meteorologists in trying to interpret that. There's one other type of satellite imagery I wanted to show you today. This is what we call a microwave satellite image. This is, again, Hurricane Dorian in 2019, moving into the Bahamas. Remember the one I was showing you that was real zoomed in on the eye, had all that detail. This is a little bit different. So what's neat about microwave satellites is they can kind of see through the clouds. And why that's important, especially when we get in hurricane season, is that can really let us see what's happening inside of the storm and closer to the core of the storm and closer to the eye. So you see this red right here? That's showing us the eye wall. And that is the band of really intense, really powerful storms that surrounds the eye of a hurricane. So this can help meteorologists figure out how a hurricane might be changing through time. Is it getting weaker? Is it getting stronger? We can kind of get under the hood, see under the clouds with this microwave imagery, and it is really helpful. All right, let me show you some of the other neat things besides clouds that we can see with our weather satellites. So in 2020, a couple of years ago, hit a really powerful tornado that moved through parts of Mississippi. And what I'm showing you here is a before and after image. Now, if you remember, one of the things I mentioned that satellites can show us now is vegetation. So on this image, basically, look, the green is trees and vegetation. Do you see this stripe of brown that suddenly appears? So watch this play back again. Before image, April 11th, everything's kind of green. And then a few days later, we've got this little brown stripe. That is actually where a tornado moved through this area, and we call this a tornado scar. Basically, it knocked down all the trees, it did damage, and we can actually detect that on satellites. That was done by an EF4 tornado. That is a really powerful tornado. We can also see things like this. When the Mississippi River gets really high, the Mississippi River carries a lot of sediment with it. And that sediment can actually help build land, but we can see it here on satellite. So look at all this shade of brown coming out around the mouth of the Mississippi River. That's all that sediment that's being carried down into the Gulf of Mexico. Here's the mouth of the Atchafalaya River, more sediment there. And then even in Lake Pontchartrain, we can make out some. What's going on here? So we have the Mississippi River. When the Mississippi River gets high enough, something called the Bonnie Carey Spillway gets open. That's to keep the Mississippi River from flooding the city of New Orleans. It takes some of the water from the Mississippi and moves it into Lake Pontchartrain to help protect the city of New Orleans. Well, that river water has a lot of sediment, and you can see it moving into Lake Pontchartrain as well. You can also see things like this. Boy, this was incredible. One of the strongest volcanic eruptions on record. This was over in Tonga earlier in 2022. But look at all these different satellite views. Look at how powerful that eruption was. And that's an underwater volcano, but all captured on satellite. You see the power. But that's something else. We can track volcanoes. And then this is a really neat image. Do you see? Watch this again. Look at this wave here. That's a shock wave that was caused by the volcanic eruption, by the volcano erupting, and that traveled all the way around the globe, we think several times. We were actually able to detect that in air pressure measurements. My home weather station here in Baton Rouge, I was able to see a little bit of a spike as this wave came across, and then the pressure dropped again. But we can see things like this on satellite as well. So pretty remarkable. Think about that very first satellite image I showed you from 1960, where it's just kind of blobs of white to show us clouds. And now some of the detail I'm showing you on some of these things now. More on volcanoes. So in Hawaii, we have Mount Kilauea, and we can use that infrared sensor on the satellites that senses temperatures, and we can pick up on where the lava is, right? So this is where things are really hot as detected by satellite. That's the lava flow from Kilauea about 4 years ago in 2018. 2017, 5 years ago, we had a solar eclipse that was visible across most of the country. What's going on this satellite image? Well, this is a visible satellite loop or visible satellite movie. That black blob is actually the eclipse showing up on satellite. So that is the moon passing between the sun and the earth, casting a shadow down. So that's a big shadow showing up on our visible satellite image. Sometimes, every once in a while, we get a little bit of snow even in our part of the world, and our visible satellites can also sometimes see some of that snow on the ground. So in 2008, this has been a while, but some of the moms and dads might remember that we had a pretty big snow event from parts of Louisiana up into Mississippi. This was the day after the snow, so all the clouds have cleared out, which allows us to see all the way down to the ground. All this white stuff is the snow that was left on the ground from Baton Rouge up to near Jackson, Mississippi. So that's the sunlight reflecting off of the snow that's on the ground, and that sunlight's being reflected back to the satellite out in space, and it's picking up where that snow is. So that particular day, we had 3 inches of snow at the airport in Baton Rouge, over 5 inches of snow in Zachary, 8 inches of snow in Amite. Pretty amazing. More recently, in 2017, we had another one of these snow events. All right, so look at this. Once again, this was December 9th. Hopefully it's played back, but if not, you can see some of the snow here. Let me just back it up and watch this as it advances again. Let me go through my graphic. Now watch closely here at the beginning as this comes on up. So you're going to see, look at the stripe of snow, and then it fades out. That's over the course of about 3 hours. So what that is showing is first it's showing some of the snow cover on the ground, and then showing how quickly it was melting as the sun came back out. But the snow extended all the way up into parts of Georgia, Tennessee, and even farther north and east. So something else we can see with satellite. Another thing, I kind of mentioned this, we can track wildfires a couple of different ways. Certainly one way we can do that, we can see the smoke. This was a huge wildfire in Northern California in 2018 called the Camp Fire. But do you see the smoke streaming up and then moving off to the west and headed out into the Pacific Ocean? After that wildfire, we can then use the way we usually look at vegetation from our satellites. So all of this is green, all that green vegetation, but look at this area kind of brown, brownish red. That's where the wildfire burned all the trees and vegetation. So it left a scar on the land. So something else that we can see. This was pretty neat. This was back in 2017, and I'm going to zoom this in just a second, but here we are in Baton Rouge, especially those we looked back into Texas on our visible satellite. There's a few things. Can you make out these holes? Here's a hole, here's one, and there's even a trail here. These holes, we think, are what we call hole punch clouds. I'm going to show you one in a second, what it looks like from the ground. And then this is called a dish trail, a dissipation trail. All of these on satellite are caused by airplanes. So airplanes, sometimes we can see these dissipation trails where the plane actually causes some clouds to dissipate. That's where the name dish trail comes from. Sometimes we can see contrails where we get condensation behind the plane and we'll get a line of clouds forming. And then sometimes we can see these hole punch clouds. So here's what a hole punch cloud looks like from the ground. So this is kind of neat. Not so much about satellite, but when hole punch clouds form, we start out with a solid layer of clouds. And believe it or not, if it's the right kind of cloud, and if conditions are just right, an airplane flying through actually punches a hole in the clouds, makes a hole. That's what happened here. So at one point, initially this would have been kind of a solid layer of clouds. An airplane flew through, made a hole. Hole probably grew for a while, and after a while the cloud may start to fill back in. So that's what's happening. It's starting to fill back in. But this was captured, I think this was maybe down around Prairieville, Gonzales back in 2015. Those are really neat when you get to see those down from ground level. All right, just want to show you a couple more things. So, you know, we talked about satellite. We usually see clouds. Sometimes it can be hard to tell the difference between clouds and fog. So how can I do that as a meteorologist? How can you recognize it? Look at this satellite movie. You see the clouds here that are moving from west to east, left to right. And then we see what appear to be some clouds around Baton Rouge. We see what appear to be some clouds in Mississippi and Alabama. But notice how these aren't really moving. These around Baton Rouge aren't really moving. So if you see something like that on satellite, it looks like clouds, but it's not moving, that's fog. You see these are moving along. Those are clouds. So that's a little tip, something you can look for. You might have heard us talk before about the dust that comes out of the Saharan desert in Africa and goes out into the Atlantic Ocean. We can see that on satellite. Here's a really neat example of it in 2019. Look at all that dust streaming out into the Atlantic Ocean. And then can you see this big area of brown? This was a huge plume of that Saharan dust moving over the Atlantic Ocean. And that dust can be important for us to track for a couple of reasons, one of which is usually when dust is out over the Atlantic Ocean, boys and girls, hurricanes have a tougher time developing. And in fact, this dust seemed to be impacting this tropical storm Beryl at the time. So that's another reason that we track it. One more thing to show you. Have you ever heard of the Northern Lights or the Aurora Borealis? Well, there's also the Southern Lights, the Aurora Australis around the South Pole, but our satellites on this neat movie way back in 2005 actually capturing the aurora, all that green down around the South Pole and Antarctica. So many things that we can see with our satellites. Hopefully you learned a little bit about it today. All right, coming up next week, we're going to talk all about this, tornadoes. So be sure to join me next Monday, 10 o'clock, same time. We will talk about how tornadoes form, how they are rated, and much, much more. So join me next week for that. But in the meantime, if you have any questions, you might need a little help from Mom and Dad, pop them in the comments on Facebook, and I'll go ahead and answer a few of those questions. All right, boys and girls, that does it for our satellite lesson today. Hopefully you learned a little bit about the different types. Visible, infrared, water vapor. We talked about microwave and some of the cool things we can see just besides just looking at clouds and rain and storms and hurricanes. Tried to run through some of that toward the end of the presentation as well. Taking a peek over to Facebook. If you have any questions, pop them in the comments. Haven't seen any so far. Seen somebody as far away as Kentucky watching, so thanks for tuning in. I saw a reference to the 504, so I guess we got some folks in from New Orleans as well joining us. So appreciate everybody that's tuned in this morning. We'll be back next Monday at 10 o'clock, as I said right there at the end. Next week is going to be all about tornadoes, so be sure to check that out. I'll walk you through how tornadoes develop. We'll give you a look at tornadoes on radar, the scale that we use to rank tornadoes, much more, a couple of videos in that presentation as well. So that'll be back here next Monday at 10 o'clock. All right, just taking a peek down to see if we have any questions rolling in. In the interim, I will remind you once again, you can visit our website, wafb.com/Caps Corner. All the lessons posted there. Now today's lesson should be posted pretty soon, but right now you can see the previous lessons are all there. I've also got worksheets that go along with each of these. So today we'll have a worksheet that has a word search with it and some quiz questions on what we covered today. Hopefully nothing too hard for you. All right, we'll take one more peek down to see if we have any questions before we wrap it up. I'm not seeing anything so far, so hopefully we taught you everything you need to know about satellites. All right, with that, we'll go ahead and wrap it up. And like I said, we'll be right back here next Monday at 10 o'clock. You can also pick up or watch any of these lessons on WAFB Plus and on our YouTube channel as well. See you next Monday at 10 o'clock.